from the audience, and since we have 8 time slots, Timon and I decided each to also do a quick lightning talk. There will be another 8 lightning talk slots tomorrow. If you have never spoken at a conference or never spoken at a Swiss Python Summit, that is your perfect chance for your 5 minutes of fame. I'm sure many of you have interesting things to talk about. You just need a handful of slides, or just one slide, or even no slides at all, as long as it's a PDF file, and then sign up tomorrow. I would love to actually have 8 full slots tomorrow. Same goes for people who are here to have questions which are actually comments. You have your own 5 minutes on stage here. Use that instead of using the questions for comments. So how this will work is somewhat similar to a poetry slam, if you have ever been to one. But first of all, who of you has been at the Swiss Python Summit in the last 2 or 3 years or so here? Okay, that's over half of you, I would say. Of those who have not been there so far, who of you has been at a poetry slam before? Okay, so for everyone else, how this will work is that every speaker has 5 minutes, and I'll be here in the back, and at some point, I will be raising one hand. And if I raise one hand, that means the speaker has 15 seconds left of those 5 minutes, and you start with a quiet, slow applause, so that the speaker can still continue their talk, but just as a little subtle reminder to them. Then at some point when I raise both hands, the speaker's time is up, and you give them a very, very loud applause, so they have no chance to continue speaking and will go off stage for the next speaker. In between, you will see those slides. If you see your name there as a next speaker, and it will be in the same order as on the poster, please go to the audio desk here in the back and get yourself a microphone, and then you will be ready by the time your talk starts. That is all I had to say. I have a clicker for you as well. And then Christian Walter is here for the first talk.
Whoop, that was one too many. So you may be aware that Python cannot just be used as a standalone programming language, but it can also be embedded in applications to provide them scripting capabilities. What you may not know is that CPython, the usual reference implementation of Python we use on desktop system, is not the only implementation of Python that can do that. There are others, and one of them I would like to talk about today is MicroPython. MicroPython is an implementation of the Python language that is optimized to work on microcontrollers, on the little computer chips that are in many electronic devices and that have very little processing powers or memory. Most of them wouldn't be able to run CPython, but they can run MicroPython. But even when you're working on a desktop application, you may be interested in embedding a small Python interpreter that is small and uses little memory. So MicroPython may fit your bill. The example I want to show you today is not a desktop application, but is this Playdate, a little handheld gaming console. Why do you want Python on this? It already has a scripting language, Lua. You can write games for the Playdate using Lua, using the official SDK. The reason I want Python on this is this. You may have seen these devices, the Pew Pews. They were made by Godomir Dopigalski, who has spoken at this conference before. And you can use them to write simple games on this 8x8 pixel display in Python using a very simple API. And they run a variant of MicroPython. But I want to run my Pew Pew games also on the Playdate. So I need Python on here. The Playdate has a microcontroller. So MicroPython is a good fit for it. But I don't want to just replace everything that's on the Playdate with MicroPython. I want to keep the Playdate OS and all my Playdate games on here. I want to embed MicroPython into an application that runs on top of the Playdate OS, along with all my other Playdate games. So I want to embed MicroPython. How does embedding work with MicroPython? MicroPython has these so-called ports that adapted to specific microcontrollers. MicroPython is written in C, and what happens when you build MicroPython for a specific microcontroller is basically two steps. The first step is a pre-processing step that pre-computes some things for runtime efficiency. For example, it collects all the strings in your source code and puts them into an efficient data structure. And then the second step is the compilation. The C compiler for your particular microcontroller compiles all that into a binary. Now there is one special of these ports, and that is the embed port. And when you build the embed port, then only the first one of these two steps happens. Only the pre-processing step, no compilation. And what you get at the end of that step is a bunch of C source files, C files and H files. Most of these were just copied from the source tree. Some were generated by that pre-processing step. And then you can take all these files and put them into the build system of your application. There, compile them along with the rest of your application with the C compiler for your target platform. And that again is a good fit for the Playdate, because the Playdate SDK also allows you to write games in C. So that's what I did. I took these files into a Playdate C project. And of course, I had to write some glue code to hook up Python to the Playdate OS, for example, give access to the file system. Or I wrote a terminal that allows me to put text on the screen for the Python REPL. That's what we saw in the previous slide. And then I had to implement the View API that gives me a simulated 8x8 pixel display and lets me read the buttons and so on. And now it works. I can run Pew Pew games on the Playdate. To make this work, I had to make some additions to the embed port of MicroPython. These are collected in a draft pull request on the MicroPython GitHub repository. It's not merged yet because I haven't totally cleaned it up yet. My project for the Playdate is also on GitHub. That's the link in the middle. I'm not done yet with it, but you can already download a first preview release. And if you want to try it here, talk to me after the talk, and I'll happy to show you. Thank you.
Then next up is Max Wittig and Pavel Sulimov. Please get ready at the audio desk.
Hi, everybody. Here's the pointer. So today I want to talk about how we provide AI for all developers at Siemens, and it's all based on open source. And let's go. So that's me. I'm Max. I'm a DevOps engineer at Siemens, and I work in the developer enablement team, which means we provide basically GitLab for the company, and we build a lot of tooling around it to automate a lot of aspects of it. For example, the user lifecycle and various aspects that are required in a big company. I'm also maintainer of Python GitLab, and we use Django a lot to build internal frameworks. But this talk is about what can developers do with Python, with AI, and what has Python to do with it? First off, what can you do? First thing you might know is the chat mode that everybody knows with ChatGPT, but there's also agentic mode where you can just tell the AI what feature you would like to have in your code, and it will try to do it more or less in a positive and good way. But it's existing with Klein, which is also open source on GitHub. Then there's also the code completion part where you can just type your code and it will try to autocomplete. I'm always using the try part, more or less. So I guess some of you know. And then you can also use image to text, where you provide an image and say, describe this, or how many people are in the picture. Then you can also use your standard REST API to reach the embeddings, to do re-rank. You can do audio to text. And this is all possible today for the Siemens developers we have, thanks to this. So we have on-premise hardware that is powered by Python. Like we have first a client, then we have a gateway so people can get their tokens to access the API. And then we have a component open source that's written in Python. It's called VLLM router, or also production stack. And this I will come to that, what they do in the next slide, but also VLLM, which does the whole inference on the machine, is also written in Python. That's also what we use, and we contribute also to both. Let's start with the VLLM that's running on the actual hardware. This provides an OpenAPI compatible API server that you can use with all the tools. You know, all the tools, they allow you to say, okay, OpenAPI, and then you specify your custom URL, and then you can use the on-premise models that we have. And VLLM supports multiple models that you can use. We use open weight models. Here, for example, you can see the GPT, OSS, the Quen, or the Pixtral for the image description, and Whisper for the audio transcription. And we made contributions here, a couple of fixes, I think, and a way so we can see usage stats for every request. Then we have the production stack, which we use as basically a load balancer. So whenever a request comes in, it gets balanced between the different nodes on the actual on the hardware, and it supports different routing algorithms. And here we made more contributions because we needed aliasing. So whenever we have an old model, for example, we can say, we don't have that model anymore. We have a new one now. So redirect it to the new one. And people mostly don't know this. And we made several improvements to the configs also, and some health checking, stuff like this, all in Python. That was it already, a short presentation. Basically, the conclusion that's missing here, the slide, is we use open source to power the LLM in the company, and it's mostly Python powered. Not bad. Yeah, if there's questions, I think I'm not over time. So, quick question. Okay. Cool. Sorry? Not yet, but we're gonna do that as well. Yeah, not yet. Okay, and there's also a blog post. Maybe if you go one further.
Oh, sorry.
There's a blog post we wrote just a few days ago where you can see this in a less speed up form and with a bit more detail. So yeah.
All right.
Thanks for the opportunity here. Ciao.
Next up will be Pavel Sulimov, and after that, Annabelle Wiegert. So please, Annabelle, go back to the audio desk to get prepared.
Thank you.
Sure.
All right. Hello, everybody. I have seen that already a couple of people left. So maybe, you know, newcomers, they don't know that lightning talks are the most interesting, with all my respect to the main track, sure. Okay, so basically, I'm Pavel, and today I want to talk a little bit about the real-time CRM with Python. And so just we prepared it together with my colleague, who is now on Cyprus, so not today here. So basically, like before moving to this lovely country, I was the head of data science team in Gibraltar. And there, obviously, you know, Gibraltar is gambling. So we had a lot of clients, and one of the issues was that when clients are making some transactions, let's say, yeah, when they gamble, sometimes they gamble very much, yeah. So we need to respond to their actions pretty fast. So we need to, for example, either get some campaign or to have retention, or then to give them some, let's say, advice on what to do next, like next best step, and so on and so forth. But the thing is that actions are seconds, and then let's say a CRM campaign can take hours. And then, imagine now you stream the data, yeah? So you want to react as quick as possible. What are you gonna do? For example, you can store it in memory. I have bad news. For example, you use Spark, and if your Spark restarts, you have nothing. Yeah, so in memory is not the best solution. There is another case, why not to use just a target database? So for example, I don't know, I use Postgres, I'm writing everything there. Okay, good idea, but the problem is that if you do just each event one write, it's gonna be expensive. And if you do it in batching, then it occurs that for example, some rule-based reactions to your client, it's gonna be super, super slow. So I mean, already the time when you should have reacted, it would go. So the solution is to use such a called data lakes, and this is like heavily recommended when you are working with like frequent clients data, I would say. And basically, for example, now I'm talking about using Spark for streaming. Then there is a very nice stuff called Delta Lake, which is this example that is specifically optimized for working with Parquet data, which is supported by Spark. And also it's just optimized for Spark itself, so that it creates like a single copy of data for streaming and so on and so forth. It's interesting that today in the first talk, it was about this count mean sketch that I never used, for example, yeah, but it was exactly about like possibility of having it in streaming. So thanks, Tim, for that hint. As I say, I didn't try, but you can. Why not? Yeah. And basically, this is kind of the result that you get. So like if you're fast enough, if you react to your clients, then for example, especially VIP clients, they're super happy when you react immediately. And for example, you get them some bonus or offers or etc. And I mean, as a business, you just make money. That's it. What do you need to do? You just need to make pip install by Spark, Delta Spark, and start making money. If you do not use Spark, you can use, for example, Flink, but just be careful. So, I mean, for example, we were using Spark because, back then it was like comfortable. Then we shifted into Flink, but now, for example, Google Cloud does not support Flink anymore as an easy integrate. That's why, let's say, it's now again better to switch into Spark. So, I mean, like nobody will tell you why he uses this or that instrument, but the truth is that it should be very well integrated with your other infrastructure. So, for example, with cloud, Google, Amazon, etc. And if you want to have like more funny stories from practice and also getting like funny solutions like this, yeah, with happy ends, then you can just follow these QR codes, subscribe, and there I'm gonna post like a lot of interesting stories. And then happy to discuss with you anything after. Yeah, that's it. Thanks so much.
Start venturing into Jungonaut space, and after that, Dave Halter. So, Dave, please go back to the audio desk.
Okay, venturing into Jungonaut space. Contributing code to an open source project is something that I have wanted to do for a few years, but I didn't really know how to get started. I have used Django for several projects and I really like it, so I thought, I could contribute to Django. So I read the contributing documentation, and there was just a lot of information, like 10 different docs pages, ticket system, forum, Discord, and I was a bit overwhelmed and still didn't know how to start. Luckily, I got the chance to participate in Jungonaut Space session 5, which is currently running. Jungonaut Space is the 8-week mentorship program where new Django contributors are like coached into making their first contributions. We get to know experienced contributors. We have weekly team meetings. We are, I forgot to mention, we are very diverse teams from around the globe. We have mentors. We have a Discord server where we can ask for help, get support, help each other, celebrate our wins, etc. So with the help of Jungonaut Space, I was recently able to make my first pull request to Django, which I'm very happy about. And and now I lost a bit, sorry. So I'm very happy about this, and I think exactly. Jungonaut Space is a program that aims at like making Django as a project sustainable by bringing in new contributors regularly and motivate us so much that we want to contribute for a long time. And I think there are some things that Jungonaut Space is doing right. It's like it's lived diversity. We are diverse teams from around the world working together. The communication spaces are very welcoming and supportive. So we are not afraid to ask questions. We get a lot of support. And we have regular check-ins with several mentors, so they make sure that even if we're shy, we're getting help. And last but not least, every small win is celebrated. So for example, for my pull request, I was like, it was a tiny thing, but like people were like cheering and stuff. So I'm really motivated to go on. Yeah, I'm really, sorry, that was premature. I'm really looking forward to the rest of the program. And at PyLady Zurich, we're also thinking about organizing some sort of Django contribution getting started event. So if you're interested or if you want to help organize it, please come talk to us. Thank you very much, and be sure to check out Django Node Space.
Thank you. Next up, we'll have David Halter, the new type checkers. After that, Stefan Schindler, and I see you already back there. Perfect. Großer Knopf.
Thank you. Hi. So I'm Dave. I wrote software called Jedi, and you have probably used it. It's part of IPython, and it's also sometimes used in VS Code. I wanted to talk to you about the new type checkers. They replace basically MyPy and Pyrite. There's 3 new ones. They're all written in Rust. They're all pretty fast. There's Ty by Astral, which has also created UV and RAF, and so they're a pretty well-known company in the space. There's Pyrafly by Meta, which is known for questionable social networks. And there's Suban by me, which I have been working on for the past few years. I'm pretty sure that almost nobody is using these projects now, but next year it will look very different, because most people in here will probably be using Pyrite or MyPy. Even if you don't use annotations, you will probably be using Pyrite in VS Code, or maybe Jedi. Or basically for auto-completions and GoTo and for all of that stuff, even if you don't use type checking in a CI environment. Because all of these 3 are also language servers. So Ty is basically the most hyped because there's UV and there's RAF, which people love, and they're really good tools. So people believe that it will be very good. It, however, lacks fundamental typing features at the moment. It also lacks IDE tools for now, completions, GoTo, renames, and all the other things that people would like to have. There's Pyrafly, which is mostly complete. It lacks recursive type aliases, which is not a big deal, I think. So it's pretty much ready to use, in my opinion. It has completions, GoTo, renames, all of these things, and more. There's Zuban, which has the cutest logo. And it's also mostly feature complete in a similar sense. It is a bit further than Pyrafly because I have started earlier. It supports completions, GoTo, renames, and of course type checking as well. So how can we measure this? How are these tools similar or not? Is kind of a hard thing to tell. There's the conformance tests. These ensure that the type checkers, MyPy, Pyrite, and so on are working in a similar fashion. There's this huge matrix that I'm going to show you that will show where these tools comply. If you're interested in this, I recommend checking this out. Thai is not in there yet because it would look pretty bad at the moment. I don't think it will look as bad a year from now. So they will also improve. This is how it looks like. It's just very big. The first one is MyPy, has a few red things that it doesn't implement. The second one is Pyrite that implements basically everything in there. And the next one is MyTool, and then Pyrofly, which is not quite there yet, but will be very soon, I think. And then there's performance. All of them are really fast. Thai is currently the fastest because they use a lot of threading. I'm not sure they will be the fastest once they have implemented everything. MyTool Zuban uses 2 times less memory and CPU, which might be good for notebooks especially because they might get hot if they use a lot of threads and they have a lot of CPUs. In case, especially for large code bases, and all of these tools are really fast anyway, so it probably will not matter that much. So my conclusion personally is you can choose any of these. I would wait with Thai for a year or half a year whenever they're there. You can use MyTool, of course, as well. But wait. So, and just in case you have a big MyPy code base, contact me. Super.
I'll show your last slide at least.
This is not important.
So next up is Stefan Schindler. You had 2 different titles for your talk. I picked the one that's not on your own slide. And
Yes.
after that, there will be
Very
Timon
good.
Erhard.
Hello, is this the button? Yes. So I'm here to talk about parsing numbers, which is very new technology. I'm up for hire as a contractor, as an employee. Anyway, let's go. So what do? Basically, we want a number here. So the big question is, how can we mess it up when you parse a number like this? And the answer is, well, what happens if the input is not what we expect, or the output is not what we expect? So what do we get here? It's number 3. All right. Does this parse? Does anyone know? Very user-friendly if our input string is with underscores. It will work. What's the output? It's the first one. It's not readable at all. Anyway, so let's use parse int with pyo3 because it's already done. Why do it again in Python? Plus Rust is fast. So if you use it in Rust directly, this is the package manager. I haven't uploaded it to PyPy or anything. So yeah, we'll see. So this is how you can use it in Rust, but you don't have to, right? You don't care. How do you care about numbers that are spaced anyhow, like floats or whatever, underscores? Yeah, that's fine. Different types of numbers. In Rust, we have to care, right? This is not the same. But in Python, we don't have to care. It's very nice that we don't have to care. But in the background, this will be done, and it can handle negative inputs, which is very handy for some old firmware or some new firmware, because sometimes people give you text output that has negative hex numbers. You can integrate it with clap. You don't know what clap is? Basically, this used to be needed for argument parsing in Rust, and now it's this. It's very short. Can we do the same niceness in Python? Of course we can. We just hide everything. Ranges, the same. You want to have a dot between something? Sure. You want to have more Python syntax with a colon? That works too. Just pass it in, you will get a range object out. Nice. The other way works as well. So in Rust, we have to be a little bit specific. No matter. We can just import it. Sadly, that slide didn't make it in, but you can output now in a slightly opinionated way. So you're outputting decimals, float or not, will group the numbers in threes, and in hex, it will group them in twos. Very nice. So with all of that, has become very easy to handle numbers and also very fast. If you want to see the Python live demo, it's on my machine. So come and find me afterwards. And yeah, you have questions? You have a minute. No questions? Wonderful. What? Oh yeah, I went to a Rust conference last week. So this is now the vlogging portion. Thank you for the question. It was very nice. I was inspired by all the food. The croissants in Paris are great. It's really hard to find a bad croissant, so I can recommend. In case you need something sweet, I can recommend the eclairs with mango filling. Very nice. And at any hour of the day, you will find something to eat. Not like in here, which closes down around 10, I think. Anyhow, technical questions? Well then, like and subscribe, I guess.
Then next up will be Timon talking about UV, and I don't need to tell myself to get a microphone because I already have one, so I'll be lost after that.
Thank you. I will do a short presentation on UV, an extremely fast Python packaging and management project manager. And if you don't know UV, then you will understand the picture with the sun, the snake, and the crab in the beginning, in the end. But just to know who of you has already used UV in production? A lot. So this is a talk I prepared a half year ago, so maybe nothing too new for you. Then, yeah, what UV does, it does almost everything what we had before in different tools. Replacement for especially high-end, especially poetry, which is kind of missing here. It's there. And it does it extremely fast because of implementation in Rust. But it does a lot of extras too. Yeah. First thing, what you can use it, you can kind of use it risk-free. Just try it out in your project where you just have the old requirements.txt. Because UV can do everything pip did. All the comments are the same. You just type a UV for your comment before your command. But it can much more things I missed a lot in the standard pip tools, and I always had to download external dependency with pip to do exactly that. For example, pip3. UV pip3, who gives you a nice tree view of your dependency, like what are my top dependencies and the whole structure instead of just putting it all together. You can sync. Something is missing in pip2. With pip, what pip did is install new things but never delete things, or you had to manually delete it. Sync does that for you. And you can create virtual environments and have UV handling the Python version for you. It will download it automatically. Then what is more suited, of course, is the projects with PyProject YAML files that will automatically handle all your dependency in a nice way, separate the rough dependency and the actual version you have in the log file. And it does it, like poetry. I personally had my fights with poetry, so I'm really glad I never have to use it again, hopefully. And it's way faster, and I got always like crazy errors in poetry, and I did not have them as much with UV. Yeah, it gives you a clean dependency management, and that's really nice. It can do a lot of other stuff. It can replace pipx with UVX or just UV tool run. It can be used to create project structures and all the other stuff. Because you all already know UV, I may go on the other side. I prepared this talk a half year ago. Now I used it more, and I find also some stuff I'm not so happy with UV. First is Astral. It's great what they provide for the community, but they are kind of really closed, have their own opinions, and always say, yeah, that's the way we're going, that's the way we support. If you do another way, that's not for you. Like I have seen tons of issues on GitHub where people wanted to, yeah, but my workflow looks a little bit different. Can I do that? And then maybe you can do that. And why do you not document it? Well, because we don't want people to know. And I have tons of issue examples. I need to update these talks, which I think is a little bit strange and maybe also not too good for the Python ecosystem if everybody relies on somebody or like this small team who decides what's right and wrong. First, I was really excited to make my first merge request for another topic in the documentation, and that's it. Simply how to first initialize a project, because there's a whole project. And my merge request, they said it was fine, but I asked them and never get merged again. I'm ghosted since then. So let's see what time brings with UV. Thank you very much. That's good.
Next up will be myself talking about, sorry, that's actually not true, the title. I mistyped my own title, that's the correct one. You might have seen this talk before 2 years ago. The title or the subtitle are new. There's one more slide. The rest is unfortunately more or less the same. So fstring.help, pyte.ult, or how I bought yet another domain. This all started when I visited pyformat.info and found it a really, really nice reference on how to use the .format method on strings. So it has nice explanation, nice examples and such. But then fstrings came along. Someone opened an issue in their issue tracker and saying, hey, it would be cool if the website also would explain fstrings. Then there was another issue. And another one, and we're talking about 2015, 17, and 19 here, and nothing happened. Looking at the activity of the project, and let me maybe zoom in a little bit there, I didn't have high hopes of that changing. Then I looked at the commits and saw, oh, there's a version 2. Okay, let's check the version 2 branch. But that also wasn't quite active. So I had this idea back in 2019, hey, let's get fstring.dev. Then I didn't actually do it, like many of my ideas. And 3 years later, I was at PyCon Germany and was like, oh my God, there are lightning talks. I can't tell people about this. Okay, let's do it. I think at the conference, actually, in the hotel. And the domain was gone. It was registered shortly after I had the idea by contact privacy ins customer 715.157.1251. If that's you, I would love to talk to you. Because there's actually nothing there. So I came up with a new idea. I was like, okay, let's go for f3.inc. But that was €100 per year, which was a bit much for a stupid joke or a stupid idea. I was okay, what else could I do? Let's go with fstring.cat, right? Well, turns out, in order to be granted a .cat domain, one needs to belong to the Catalan linguistic and cultural community on the internet. Obviously, like Nyan.cat. So that idea was out too. And then I discovered, okay, fstring.help, reasonable price point, and I set it all up. more or less live coded at PyCon Germany and still pretty much around, a web page which teaches you all those little nice syntax thing in F strings based on examples. Starting with like basic formatting and then going way, way beyond that with this like mini formatting language you get with F strings. Then I got contacted by Trey Hunter, a Python trainer who made something very similar at around the same time as a cheat sheet in a more compressed table form. So we agreed to host that as well on fstring.help/cheat and also linked from the main page. Now, very recently, maybe like 2 months or so ago, I bought yet another short domain, pyte.zd, where you can find things from the PyTest documentation basically based on the API name. So pytest/fixtures, pytest/raises, pytest/parameterize, and so on. It will take you straight to the right place in the PyTest documentation. And on the main page, you will get a list of all available links there. And then fstring.help, you can find more about me on those links. Thank you, that's all I have. And that was it for the lightning talk. So there should be a social event/apero thingy going on outside very soon. Thank you very much.